You've looked at rainbows your entire life, and you've never actually seen one, not the real one. Why is it always an arc? Why never a straight line or a smear across the sky? Why does it vanish the moment you walk toward it? Why does the red always sit on top every single time, in every country, in every rainstorm on the entire planet? Why can two people stand side by side and technically be looking at completely different rainbows? And why does a double rainbow have its colors flipped the wrong way around? The answer involves geometry happening secretly inside millions of tiny water spheres every single time it rains. But here's where it gets weird. The arc isn't a feature of the sky. It's a feature of you. A rainbow is just light being sorted by water. That's the whole thing. But the sorting happens in a wildly specific way that forces light to only ever reach your eyes from one exact angle. You've probably made one without realizing it. Stand with your back to the sun and spray a garden hose on a bright afternoon. There it is, hanging in the mist, aimed right at you. Every rainbow you've ever seen, every single one, was aimed directly at your eyes and only your eyes. So what's doing the aiming? Here's the misconception almost everyone carries. Rainbows feel like objects. They feel like things that exist out there in the sky, the way clouds exist, the way mountains exist on the horizon. You point at them, you photograph them, you drive toward them hoping to get closer. It feels completely solid and real, but there is no rainbow sitting in a fixed spot in the air. It's not an object, it's a projection, rebuilt fresh from scratch for every single person watching. This is the part everyone misses. Two people standing just 10 feet apart are seeing slightly different rainbows. The angles are different for each set of eyes, which means the exact set of droplets sending color to your eyes is different from the set sending color to the person next. To you, you cannot share a rainbow, not really. You never have. But that still doesn't explain the arc. Why not a blob? Why not a flat smear across the sky? Why always that same perfect curve every single time? Each raindrop is doing two jobs at once. It acts like a tiny prism and a tiny mirror at the same time. Light enters the front of the drop, bends as it crosses into the water. This bending is called refraction, the same reason a straw looks snapped in half inside a glass of water. Then the light bounces off the back wall of the drop like a mirror and bends again on its way back out the front. Now here's the key part. Different colors bend at slightly different angles. Red light exits at about 42 degrees from the direction it came in. Violet light exits at about 40 degrees. That 2-degree gap sounds tiny. And it is, but it's everything. It's the reason you see a clean band of separate colors instead of just a white smear of light. Now imagine not one drop, but millions hanging in a curtain of rain. Only the drops sitting at exactly 42 degrees from your eye to sun line will send red light to your eyes. Only the drops at 40 degrees send violet. Drops at 41 degrees send orange and yellow. Every other drop sends its light somewhere else, to another observer, or off into empty air where nobody's watching. The arc you see is just the visible edge of an invisible cone that stretches from your eyes outward into the rain. You're standing at the tip of the cone. The rainbow is the rim. Red sits on top because the drops at 42 degrees are physically higher in the sky than the drops at 40 degrees. That's it. That's the whole reason. Always. No exceptions. Anywhere on Earth, in any rainstorm, in any century, the geometry is locked. But here's where it gets crazy. What happens when light bounces twice inside the drop instead of once? You get a second arc, higher up, floating above the first one. That's your double rainbow. But because of that extra bounce, the colors exit in reverse order. Violet ends up on top. Red drops to the bottom. The whole color sequence is flipped compared to the first arc, and the gap of sky sitting between the two arcs, it looks noticeably darker than everything around it, like a shadow band floating in the air between two glowing curves. That dark strip has a name, Alexander's Dark Band. It sounds like a secret society or a prog rock album, but it's completely real and it's been documented since ancient Greece. One widely accepted explanation is that light escaping at the wrong angles bypasses that zone entirely, leaving it starved of brightness while the sky around it stays lit. And then there's the fog bow, the rainbow's pale, almost invisible cousin. Fog droplets are dramatically smaller than raindrops, sometimes hundreds of times smaller. And because they're so tiny, all the colors blend together before they can separate cleanly. What you get is a wide white or faintly colored arc that looks ghostly and washed out like a rainbow that forgot what it was doing. The size of the water drop directly controls how vivid the colors appear. Big raindrops make sharp, punchy rainbows. Tiny fog droplets make something that looks like a rumor. Now go back to 1637. René Descartes is sitting in a dim room somewhere in the Netherlands. He's holding a large glass sphere filled with water up to a window. Basically, a handmade raindrop the size of a small melon, maybe the size of a grapefruit. He is not admiring it, not painting it. He is measuring it with obsessive precision, tracking exactly where light enters, where it bounces, and at what angle it exits. He maps the angle. He gets roughly 42 degrees. He writes it up and publishes it. And for the first time in recorded history, there is a mathematical explanation for why the rainbow sits exactly where it sits in the sky. But Descartes figured out the where. The angle, the position, not the why of the colors themselves. That part stayed open. Therefore, decades later, Isaac Newton picks up a glass prism in the 1660s and aims it at a narrow beam of sunlight coming through a curtain. He expects the glass to tint the light, the way stained glass adds color to a window. Instead, the white beam splits into a full spectrum, red, orange, yellow, green, blue, violet, spread across his wall. The colors weren't added by the prism. They were already hiding inside the white light the whole time, packed together, waiting for something to pull them apart. Two of the sharpest minds in all of human history had to tag team the rainbow across 30 years just to fully explain what you see after an afternoon thunderstorm. And now the part that should genuinely change how you look at your everyday life. You've been surrounded by this physics your entire life and never noticed it by name. The shimmer on the surface of a CD or DVD comes from thousands of microscopic grooves that split light the same way a prism does. Your old music collection was running a light show the entire time. Soap bubbles split light too, but through a different trick. The thin film of soap bends incoming light waves so they collide with each other, and depending on how thick the soap layer is at any given spot, different colors either strengthen or cancel each other out. That's why the colors swirl and shift as the bubble stretches and thins before it pops. An oil slick on a wet road after rain does the exact same thing. Thin film of oil sitting on water, same color physics, just a dirtier setting. A diamond sparkle isn't an accident. Jewelers cut diamonds specifically to bounce light around inside the stone as many times as possible before it escapes. Every bounce separates the colors a little more, and the more separations, the more fire and flash you see when you tilt it. Camera lens flare, those streaks and blobs of color in photos taken toward a bright light source, happen because light bounces between the glass elements inside the lens, separating and recombining along the way. Those little prism stickers people hang in windows to throw rainbow patches across the walls are literally doing what Descartes did with his glass sphere in 1637, just mass-produced. A waterfall generates a permanent mist cloud, and if you stand at the right angle with the sun behind you, you'll see an arc locked in place that doesn't move, a stationary rainbow anchored to the spray. A garden sprinkler at the right time of morning or evening does the same thing on a smaller scale. Dew sitting on a spiderweb at sunrise means every single tiny droplet clinging to those silk threads is acting as its own personal rainbow machine, each one aimed at a slightly different observer. That smeared color you see on a foggy car windshield when headlights hit it at night. Related, the halo that sometimes rings the moon on cold nights or circles the sun on winter mornings, that one's actually made by ice crystals. High in the atmosphere, doing a very similar angle trick, but locked in at 22 degrees instead of 42. And butterfly wings, beetle shells, opal gemstones, none of them use water at all, but microscopic structures built into their surfaces split light by size the same way, producing shifting colors with no pigment involved. The rainbow isn't just a weather event, it's a principle. Light plus something to bend it plus the right angle equals color. Here's the honest catch, though. You can't summon a rainbow on demand. The sun must be low in the sky, below about 42 degrees of elevation above the horizon. If the sun is too high, that cone of color angles downward into the ground instead of upward into your view, and you see nothing. This is why rainbows happen in the morning or late afternoon, not at noon in most places. In tropical regions close to the equator, the sun geometry can work at midday, so midday rainbows show up more often there. And here's something worth rewinding for. There is technically a full circle rainbow happening every single time. A complete 360-degree ring of color exists. You just can't see the bottom half because the ground is physically blocking it. From an airplane flying above a rain shower, you can sometimes see the entire circle below you, a perfect unbroken ring with no ground cutting it short. The Earth is hiding half your rainbow every time. Has been your whole life. A rainbow is a live geometry reading. You are the origin point. Move, and it moves with you. Chase it, and it retreats, because you're the one drawing it forward.